Let me show you how to do the Vernier trajectories lab. What I'm going to do here is I'm going to do challenge 1. So on the desktop you'll see a little folder that says Vernier 1, 2, 3, 4. So you want to double click the first one and it'll open up like this. And you should see it'll be like some velocity and whatever, and we're going to change that. Okay, so the first thing I'm going to do is I want to pick a distance that I want this thing to be out, and I want to calculate the value that I'm going to put in here so that it goes in the little hole there, right? So I'm just going to pick something like 13. Right, and when I hit enter, notice that the thing moves over to 13 meters, right? So that'll be my distance. You're going to pick a distance and your partner will pick a different distance, and neither one of you will pick 13 meters. Okay, and what we're going to do here, the basic idea is that we are going to calculate the value that we need to get the ball to go into the little hole there, right? So what you're going to do is you're going to set up horizontal, vertical, X, VI, VF, A, and T, and you'll do that vertically as well. And these are still the same thing. So that's 0. This one you actually have to use negative 9.81. Okay, because the simulation is pretty accurate, and that's a pretty small hole. Okay, our initial velocity vertically will be 0, right? And then vertically, notice that we start at 25, but the target is down at 0. So the vertical displacement is down 25. Okay, and that'll be true for everybody, right? I chose 13 meters as my horizontal distance. You're going to choose, of course, a different thing, right? So that guy goes right there. Okay, and then ultimately what I want to do is I want to calculate what these guys are. Okay, and that number, that's the same number, is going to go in there, and I'm going to see if I can hit the target. Okay, so to do this, what I want to do is I want to solve this side. Let me just give you a clue. On the vertical side, you know X, VI, and A, and we can find T using this formula. Okay, so we're going to just plug that in. This is X is negative 25. So negative 25, right, equals 0, right? The initial velocity is 0 plus 1 half negative 9.81 and t squared. And this is, of course, one of the hardest things to solve, right? So solve along with me, right? And anyway, so you'll solve that. That'll give you the time, okay? That'll give you the time. The time should be something like 2.2 something, right? But do it, calculate that. Don't round it off too much. You'll get that time. And then to find the velocity, you're going to use velocity is x divided by t. Okay. Now I'm just going to make a wild guess. You're not allowed to guess, but I can guess. So I'm just going to guess what this velocity might be. Now my guessing might involve actually a calculator. Okay, so here we go. I'm just going to guess that maybe this will end up being 5.758. Right, so once you figure out what this is, 5.758, right, figure it out and type it into there. Okay, so let's see if I can type. So 5.758. All right, there it is. Okay, are you ready for this? Oh yeah, who's your physics teacher? There we go. Let's see if we can get it to stop. Trying to click. Come on, baby, I'm clicking. There we go. It's reset. I'm like going through so many layers of software here, right? So that's your thing, right? So you pick a horizontal distance. You type it into that box, right? Okay. The vertical distance you read off of there. You solve for the time. I'm not going to do it because you need to do it yourself. This is your lab, right? And then you basically just go 13 meters divided by that time, and that'll give you this horizontal velocity. Type it in right there. Hit run. It should go in. There you go.